We are about to execute this script to carry out data upload and MapReduce task in our database. First, we are going to employ a multi-threading approach to upload Twitter data, and following this, we will run the script for uploading external data. As you can see, our data will be transferred to the CouchDB within our main server in the same IP. And also, once our data has been uploaded, we will carry out a MapReduce operation on it. So for this, we'll connect to CouchDB within our Twitter server. Here is our CouchDB interface within the virtual machine. This one is the main server. The database here on our Twitter server is identical to the one in the main server. As you can see, besides the database that's constantly crawling for mustard down real-time data, no other database are present at the moment. So now we are going to run the script on our main server. The display shows that we have closely to 130,000 pieces of Twitter data. So returning to our CouchDB and refreshing it, you can see a new database for Twitter data has been added. If we click to open it, you can see every individual tweet that we have proposed. If we continue to refresh, you can observe the numbers within the database constantly increasing. Similarly, if we refresh the CouchDB within the Twitter server, we can see that the Twitter data here is also being updated in the real time. This is because the implementation of a CouchDB cluster design. Although the data was uploaded to the main server, the Twitter server replicates this data, thereby enabling synchronized real-time updates. So due to the large volume of Twitter data, the total upload process takes about 40 minutes. So once the Twitter data upload is complete, you will notice a few empty databases appearing in CouchDB. These are named after the external data databases. So if we refresh the page, you can see the data is coming into the database. Here you can also see the message data tweet MPI finish and data push external start. This indicates that the first script of Twitter data has run successfully, and the script for transmitting external data has started. Back in CouchDB, refreshing the page, you can observe that the Vixport database is being updated. Also same for tweet server. So the output shows here is the Vixport data. We have split Vixport into 30 small folders to upload. Now you can see that all the data upload has been completed, and the MapReduce script has also completed in this execution. We now return to the database. You can see that the database contains the design doc and view that were newly created in the script. Upon opening the view, you will find the MapReduce function we made. Given the large volume of our data, it takes a while for the MapReduce result to be generated. The view displays each tweet in JSON format that meets our map conditions. We need to wait for our MapReduce task to be completed before uploading the calculation results. So first, let's check whether all the views has been successfully generated. We've also performed MapReduce on the external data databases, and their results will be returned to the MapReduce along with the Twitter data. After the checks are complete, we run data push MapReduce script. Upon refreshing the database, you will find that all our MapReduce results have been returned to the CouchDB in the Twitter server. So since we have a cluster setup, these databases are also contained within the main server. The backend can directly call the database for the next step for operation.